Hello students, so let's see the further questions, okay, of 2 marks each. So here is question number 35. A force P is applied as shown in the figure, okay, here at a distance x. So in this question you have to find out at what distance the P should be applied so that the displacement at A is equals to 0, okay. So this type of questions, see, you have to apply your basic strength of material here, not strength of material, but you can see a basic mechanics. You can replace this P, or you can transfer this P to A such that P is also acting here, as well as a moment is also P into L minus X is also acting at A. See, in the next question I have explained in the next figure, okay. So in this way, so it means the displacement at this point, at this point A, should be 0. So P is making the point downward, pushing the point downward, and this moment is lifting the point A upward. So the deflection due to P should be equals to deflection due to this moment. Then only this point A will be at that position only, or the deflection will be 0. Okay, so we know, because of the point load as a cantilever, in a case of cantilever, this is the general formula PLQ by 3EI, and in case of a moment, this is the general formula ML square by 2EI. General formulas you have to remember, there is no options. You don't have that much time, so that you can calculate this formula and you can use it. This is not a subjective paper, this is actually an objective paper. GATE is an objective paper, so you have to be very quick. Okay, so delta 1 should be actually equals to delta 2, so that then only the deflection will be 0 at point A. So by substituting and by doing the simple calculation, you will get x is equals to 1 by 3 L. Okay. See, question number 36. This question belongs to cam and follower, but you don't require the knowledge of cam and follower here. Since in 2014, the cam and follower chapter were not included in the syllabus, but then also the students can solve these questions without just having the knowledge of basic maths. Okay, here a question is said that which option will have a maximum amplitude. This is the representation of amplitude. Xt and yt are the parametric equations of amplitude, and you have to consider, you have to find out which option will give the maximum amplitude. Okay, so see, by looking at the option, if you can say x square plus y square, if you will take the square root of that, you will get the amplitude. Okay, so in which case x square plus y square whole root is maximum. It clearly understand. See, cos square t plus sin square t whole root is 1. Okay, cos square t plus 2 sin square t is 1 plus sin square t. Sin value is maximum 1, so it can be 2. Maximum value can be 2. Okay, but it is not possible. Why? Because whenever no, it is possible. Okay, now let's see the C, option C. X square means this complete half plus cos t whole square plus 2 sin square t. So this option will give you the maximum value of x square plus y square. Okay, so you can just do it as a calculus. Take x square plus y square as a function and calculate the take the df by dt, means the function of that, differentiate with respect to t and equate it to 0. You will get t is equals to 0, and at that t is equals to 0, double differentiate it and then find out the value. You will get option C will give you the maximum value. Okay, maximum. So option C is the answer. Okay, in that way also you can do. Another method is, here I have just explained in a brief way how to solve this, so just read it. Okay, you will get easily. Now let's see the next question. This is also a question from mechanics. A 4-wheel vehicle of 1000 kg mass having wheels of radius 0.2, okay, and all the wheels are identical and revolving at 10 radians per second. So if suppose a brakes are applied on all the four wheels together, and so the vehicle such that the vehicle stops in 10 seconds, so you have to find out the braking torque. Okay, so as soon as you will hear the term braking torque, you should be knowing torque is equals to I into alpha. Alpha is angular acceleration, I we know that it is I is the mass moment of inertia. Okay, mr square or whatever is the value of r as per the configuration. So I we know, we require alpha. How we can calculate alpha? We know time. So as we know, v is equals to u plus at. So in case of circular motion, we can write omega f is equals to omega I plus alpha t. Okay, in this here I have written this second line. Okay, so as we know, omega f is 0 since the vehicle gets stopped in 10 seconds. So we can easily find out alpha is equals to 1 radian per second. So torque is I into alpha, and you will easily get 10 Newton meter. Okay, see guys, the next question. This is a very interesting question. Okay, whenever you will have a 90 degree, you have first, let me explain the question. A slider crank mechanism. This is the crank, this is the follower, this is the slider. Okay, this is of 60 mm length, 240 mm length, and 90 degree is given. The angular speed of crank is 10 radian per second clockwise. Okay, so you have to find out the speed of the slider. Here a direct formula can be used, which is given in SS Ratan book, Theory of Machines, dynamic analysis of slider crank mechanism. You can refer it, but I don't prefer to remember the formulas, because in GATE many subjects are there, and how much formula you will be remembering. So it's you can see how to solve this. See, this is a crank, it's rotating at 10 radians per second. So what will be the velocity of this point, the connection, the joint between crank and follower? This will be 60 into, or 0.06 in terms of meter, if you want to say 0.06 into 10, which is 0.6 meter per second, which will be in the direction of follower. Okay, the same velocity will be transmitted if suppose there was no slider, and if the point, this point is having 0.6 meter per second velocity. So this point will also have 0.6 meter per velocity in this direction, in this direction. Okay, so you can easily resolve that 0.6 meter per second in two direction, in parallel to the slider and perpendicular to the slider. Okay, so you should be knowing the angle at which you should resolve. You can easily find out the angle, which is tan inverse of 60 by 240, which is around 14 degree you will get. So just resolve 0.6 into cos of 14 degree, you will get around 0.58. So the range is given as 0.54 to 0.66. So that is the answer. Okay, and if you want the exact result, you can just put the formula and calculate in the calculator. You will easily get the answer. So answer is around 0.58. Okay. So the next question, this question comes from linear programming. It's a very easy question, even class 12 guys can also do this. So consider an objective function z, 3x1 plus 9x2. You have to find, these are the constraints given, so you can find out, you have to find out the maximum value. Okay, so by solving, if you want to plot also, you can plot is a very, what to say, an easy and a good way, and as well as the efficiency is maximum in that case. But what I did is I just solved these two equations. As I can see, the objective function is 3x1 plus 9x2. So both are positive. If x1 is also positive and x2 is also positive, then I will get the maximum value of z. So I solved and I got the value as 12, minus 4, 12, minus 2. So for these two values, I will get the maximum value of objective function as 18 for 12, minus 2. Okay. Now let's see the last question for this video. Okay, a mass spring system is given, and it is the mass is excited with an exciting force, with a with a sinusoidal or a harmonic exciting force. Okay, 10 cos 25t.